So today the topic that you're going to study is the sorting method is known as merge sort. Okay. The merge sort, like binary search, is a method known as a divide and conquer method. Okay, divide and conquer. So why is merge sort and maybe binary search known as divide and conquer? Because given a problem, suppose you are having a problem, a sort of a set of elements like this. The elements are divided into halves, and you keep dividing the problems into smaller halves till you find a solution in some half. So basically, given the initial problem, you decompose the problem into smaller halves. Okay, and you keep decomposing that problem into still smaller halves till somewhere in one of the halves you find the solution. So that we had seen in binary search, how given an initial array, we first found the midpoint somewhere here. Okay, and based on the midpoint we decided that we have to search in the lower half or the upper half. Okay, so suppose based on the midpoint we have decided that we have to search in the lower half, then again we find the midpoint, then again we would decide whether to search in the lower half or the upper half. So suppose again we choose the lower half, again you find the midpoint of that, and so on. So basically what you are doing is to keep dividing the initial problem into smaller problems, and then you somewhere at the end you find the solution. Okay, so the merge sort also follows a similar approach like your binary search. What it will do is, given the initial array to be sorted, it will divide the problem into smaller halves, and then it will find the solution. So the process of decomposing the problem into smaller halves is known as divide, and the process of finding the solution is known as conquer. Okay, we will learn about more of this in your future subjects, but this is just a small introduction to you. Okay, so directly I am going to teach you this method, merge sort, how it works. So there are two ways you can do merge sort. One is using recursion and one is using iteration. We're going to look at both the methods. So the first way is using recursion. I just want you to copy this first initial array. Copy this array on your books, the initial array. Now while solving you require so much place in your books, so maybe you can use a double page or see how much place you require in your books. Okay, so just copy that initial array and then I'll tell you how we have to do merge sort. Our aim is to get this array sorted. Siddesh, you need to join on time. So recursive approach is also known as top-down merge sort. Okay, I hope you have copied this array. Copy this array 8, 5, 89, 30, 42, 92, 64, 4, 21, 56 and 3. Okay, now as you can see here, we are doing first initially you are going to do the divide phase. Okay. So in the divide phase, your aim is to keep dividing your array till you reach to a size of one element. So keep decomposing or dividing the array till you reach this level where there is only one element. Okay. And once you reach to this stage, then you start the conquer phase. I'll teach you how to do the divide and conquer. So it is not very difficult, just pay attention. So first, when you're given these elements, then count the number of elements. Okay. So count how many elements are there in the array. So when you count in this array, there are total of 11 elements. Divide the array into two halves. Divide this initial array into two halves. Now, as you can see, we are having odd number of elements here. So when you are having odd number of elements, one of the divisions will have a bigger size than the other. Okay. So one of the sub arrays will be of a bigger size than the other sub array. So in this case, in your textbook, they taken the first sub array as a bigger array compared to the second one. But we could have also taken this one as the smaller one, the first one, and the second one as the bigger one. It is okay like that if you do that also. But we will follow this method of your textbook so that all of us get the same answer every time we solve this. So you will follow this method. Okay, when you're solving for IT of your exams, please follow this method, wherein when you divide this array and if you're having odd number of elements, then the first sub array will be bigger compared to the second sub array. But like I told you, both options are correct if you do it. Okay. So you have to just divide it. When you divide this array into by finding the midpoint, you will find that the first array will have 6 elements and the second array will have 5 elements. So you just divide this. So the first 6 elements means still here. So you divide it like this, like it is shown here, and the remaining 5 elements you will put here. Okay. Afterwards, you will continue this process. Now the sub arrays will get further divided. Okay. So this is having now 6 elements. You divide it further. So you will get in here 3 elements and 3 elements. Similarly, this one is having now 5 elements. So you will divide this further. So you will get here 3 elements and 2 elements. So you have to keep dividing. So how long you have to keep dividing? Till you reach this place, this step, wherein each array element is subdivided. So you are having separate, each element is a separate array kind of sub array. Okay. So till then you have to keep subdividing till you reach this step. Can you all do this till here? It's just dividing. There is nothing, there is no formula as such, just the midpoint formula you have to remember. There are 3 elements and 3 divided by 2, you will get 1.5, but you round it up and you will get 2 and 1 and so on. Can you do this on your notebooks? Do the divide step. If any difficulties in understanding, you can type here in your chat. I will solve your difficulties. Anyone has any difficulty in dividing it? Don't copy. Just try it on your own. You can just type in the chat when you're done with this. You're not expected to use rulers and all, so you can just do it freehand as long as the lines are come almost straight. Have you all finished it? Do till here. Okay, Ruben has finished. What about the others? Have you all finished it? Okay. Okay. So let's continue then. Pay attention, then you can do it on your books. Okay. I'll explain you now. This is the main phase where we are going to do the sorting. Now, when you're doing sorting, first I'll tell you the common mistakes that you'll do. Okay. So once you reach this step, okay, you should have all elements as a sub array. You can see here in the textbook what they have done is actually they have got these elements here as single elements here in this step. Okay, and they have started combining from this step onwards. But if you wanted, you could have just written this as single element here as 56 and 3 like the other elements. Okay, you could have just written this like this here, 56 and 3. Okay, just like these elements in this row. Or you could start with the conquer step for this. If you don't get confused, then you can start with the conquer step for these elements from here itself. Okay, so these have already got divided into, decomposed into the minimum division that you could have done of one element. So once you get one element, you have to start with the conquer. For these two elements, the conquer has started here, and for all the other elements, the conquer starts from this step. Okay, so you can follow, maybe you can follow this also if you understand what is happening. Otherwise, if you are getting confused, you could always write this 56. You could draw the arrow like this. Okay, and return here 56. Draw arrow, one more arrow like this, and return 3. Then so you could have started with the conquer step along with the others. Okay. Okay, so I'll teach you what is now the conquer step. It is very simple. All you have to do is, once you've got this element separated into one each, you have to start combining them. Okay, as you start combining them, you have to sort and write. So here you can see here, this two elements are present. The same two elements you have to combine. Okay, you cannot combine, for example, 5 with 89. Okay, these two, in this previous step, before this step, the preceding step, you had 8 and 5. When you combine also, you should combine these two elements together, that is 8 and 5. But when you write it in sorted order. Okay, similarly, this now 89 you could have written here, could have written 89 here. Again, you could have written 89 here. Okay, but in your textbook they have already shown directly 89 to the next step, because till then 89 is not going to be touched. Okay, but if you wanted, you could have written 89 like this. So coming, I'm explaining the step that I've highlighted in green. Okay, so coming back here, in the next step you combine this 30 and 42. Why I'm combining 30 and 42? When the preceding step 30 and 42 were together. So when I combine this together, that is, I'm conquering them. This is the conquer phase has started. When I start conquering, you write in sorted order. These 30 and 42 are already in ascending order. When I write, there is no change. Whereas here 8 and 5, when I was writing, I have to change the order. 5 and 8 had to be written in the opposite order of what was already present in the previous step. So it was 8 and 5. Here when I wrote it, it will become 5 and 8. Similarly here, like in the previous step, if you wanted, you could have written here 92. Could have written here 92. And then again written 92 here. Okay, instead of showing this long arrow all the way to the bottom step. Clear? Similarly now, when you are solving this part, so you are going to sort and write. So you are going to combine both of these, 4 and 64 you are going to write. Okay, make sure you combine these two elements which were there in the previous step. You cannot combine 4 with 21, or you cannot combine 64 with 92. Okay, look at this properly. As you have divided, you are solving this step. So when you are writing for this one, to look at the preceding, what was combined. So 64 was combined with 4. So as you are writing the sorted order also, you have to write those two elements that were present here. Many students make this mistake. That's why I'm pointing out. Some students will combine 64 with 92, or some will combine 4 with 21. You cannot do that. Okay. Again, like I told you about 89 and 92, you could have written here 21. Again here also you could have written 21. So when we are decomposing, that time see here we are divided this. So we have got here almost elements of having 5. Here there were almost elements of 3. Here there were elements of 2 or 1. Here there were elements of 1. Okay, and this was elements were 11. So now when we start combining, again we are getting the same order back. So here we will have elements of 2 or 1. Here we will have elements of 3. Here we will have elements of 5 or 6. Just like we had here, 5 or 6. And at the final we will have 11. So this same order has to follow what you had done while dividing. So while combining, again you must get the same order back. Clear? So now in the next step, you combine these three elements. So you will combine 5, 8 and 89. So you will combine and put it in sorted order. So this step and this step is this number of elements in those sub arrays will be the same. So here it was 8, 5, 89. Here also it is the same elements, but they are in sorted order. Okay. Similar here, you will combine 30, 42 and 92. and write them in sorted order. Here you will combine 4, 64, 21, write them in sorted order. Okay. Again, instead of drawing all this arrow all the way down, you could have written here 356 and you could have written here 356 and continued. Are you getting what I'm trying to tell you? How to combine? Is there any doubts about this? So basically, all you have to do is combine, and as you combine, you should have the same elements like your preceding step that was there on the divide side. So this step of where you are merging 5 or 6 elements should be the same. The number of elements in that array should be the same. The element should be same. You cannot have 64 in this side when you are merging here. So as you are conquering here, you are merging the two sorted arrays. And as you merge the two sorted arrays, you write them again in sorted order. Therefore it is known as merge sort. Is it okay? Anyone has any questions about any step here? Is it okay? Can you just complete this one then, if you have understood it? So any doubts, students, about this method here? Anywhere you want me to explain? Okay, I'll keep this slide open. You can check out your answers here. If you have any doubts anywhere, you just let me know in the chat. Once you are finished with this, you just let me know so that we can learn the second method of merge sort. So remember, this recursive merge sort is also known as top-down merge sort. So in the exams, they may tell you, they may give you some elements and tell you to do top-down merge sort. So if you are told to do top-down merge sort, means you must do this one, recursive merge sort. So I will finish drawing it. Okay. Then let's proceed to the second one. So the second one is a bottom-up merge sort. Okay. Again, we are taking the same array. This is the same array we are taking for both the examples. Okay. The approaches are different. The bottom-up merge sort is also known as iterative merge sort. So basically, we start from the opposite way of the recursive one. In the recursive one, we were taking the entire array, we are dividing it into elements, sub arrays of one, and then we were merging them. Okay. Here in bottom up, we take a opposite approach. We start with each element. Each element in that given elements will be taken as an individual sub array. Okay. So you start with size equal to 1. Then in the second step, you take size equal to 2. Basically, you are doubling the size. In the third step, you will take double the previous size. So it will be 4. And with this, if suppose you solve the problem, then that's it. Otherwise, you keep doubling the size. Okay. So then in the next step, you will take size 8 and so on. So these sizes as such are not fixed. There's no number of how many iterations you can take. You don't know in advance as such. Okay. So keep doing it till you get the answer. So the way you do it is pretty simple. You start with this size 1. Okay. Start merging these two elements. So you take one element from here, one element from here. Okay. And merge them. So once you merge them, you write them in sorted order. So 8 and 5 you will write as 5 and 8. Similarly, you take the next two elements, merge them and write them in sorted order. So you will write 30 and 89, 42 and 92, 4 and 64, 21 and 56. Now, as we know, this array is having total of 11. So we can do this for the first 10 elements. You can do the merging for the first 10 elements. We are done here for the first 10 elements, the merging. For the 11th element, there is no other element to merge. So just write it down as it is. Okay. So this tree will be written as it is. All these other elements will be written sorted and merged. But this tree, because it is the odd element, you're going to just write it down as it is. Okay. Now we start merging elements of size 2. So we'll merge this one with the corresponding neighbor having a subarray of size 2. And as you merge them, you will write in sorted order. So you will write here, for example, you write 5, 8, 30, 89. Okay. And you draw these arrows to show that these have got merged. You'll merge this one 42, 92 with 4 and 64. So merge them and write in sorted order. Okay. So as you are merging them, you write them in sorted order. Now here we have said the maximum size will be 4. Okay. So here this one will not be of 4 elements. This will have only 3 elements. Maximum size of the sub array could be 4. So this first one and second one is of size 4. The third sub array will be of size 3. Okay. That's okay. Because here we are having only one element. So when you are writing, merge and sort them. So here you will get 3, 21, 56. The next step we are saying maximum size of the sub array will be 8. Therefore you merge this sub array with this sub array. As you merge and write them, sort it and write. So you will get this 4, 5, 8, 30, 42, 64, 89, 92. Now, since I was merging two arrays, these two arrays I merged. Okay, there's nothing for this subarray to merge. There's no more subarray here to merge. This subarray, you just write it down as it is. Now in the next step, the final step, you merge this subarray with this subarray, and as you merge, sort it and write. So when you sort it and write, you will get this as the output, the final sorted array. So well understood. Any questions about this? So I'll come to the chat, and if you have any questions, you can just type there, or you can unmute yourself and ask. That depends, Siddesh, that depends on the type of data that is given, okay? In the order of the data. So in some certain cases, the merge sort is more efficient than selection sort. It all depends on, I will come to that criteria later on, okay? I'll explain about those criteria later on. So in these two methods, do you all have any doubts about today's methods? In the recursive method or the iterative method of merge sort? Has everyone understood? Okay. Then